Front-end interview. Let's design an autocomplete component, something like you might see on Google or Facebook. So when the user types based on what they typed, they'll be shown a list of several suggested results. And for this practice, let's assume that there's a backend API provided, which will return a list of results based on the search query. And the front-end component should be reusable, and the input field UI and search results UI should be customizable as far as their appearance and several behaviors, which we'll talk about. So some initial questions we should probably ask. Are we going to support rich results, that is images and things like that, or just pure text-based? So we can start by following Google and Facebook's model, where we show just a thumbnail image and some associated text. And what devices will this component be used on? So we can assume it'll be shown on any type of device, right? Mobile, tablet, desktop, bearing in mind that, and this is a result from a Google search, in 2024, this year, an estimated 56% of global internet traffic will originate from mobile devices, while desktops will contribute 39%. So some mobile first considerations will definitely be worthwhile here. Should we support fuzzy search? What the heck is that? Well, we'll cover this later. It's basically just thinking about how can we account for the possibility that a user might make a typo, but we still want to show them the results based on what they actually intended to search for. So let's take a look at a diagram of what this system might actually look like. At a quick glance, we've got the user typing into the input UI. This field gets fed into some kind of controller service. The controller will check the cache to see if there's already results for that input. If there is, these cached results will be fed back to the UI. And if not, the controller will check the server. Then those results are passed to the results UI, which is shown to the user. So let's talk about defining our autocomplete component's interface. In other words, what are the props or options that this component should receive? So there are a bunch of different options that this component should take in. We want it to be basically as flexible as possible so that it can be potentially used in a number of different scenarios. So it should have a lot of customizability. So we can pass in the number of results to be shown in the results UI. We'll talk about this a bit more later. We should pass the URL of the server API. We should pass some handler functions for event listeners, for example, input, focus, blur, change, select. For any one of these events, we want the developer to be able to customize the resulting behavior. And we can pass in some customizable way of rendering and styling the component. There are a few different ways we could do this. We could pass a theming options object, where the key value pairs are CSS styles, or we can pass a series of class names as individual props, which get attached to various tags, and then we can assign them styles from the parent component. And if we need even more customizability, we can also pass render functions for various subcomponents. For example, maybe in one implementation of the autocomplete, we want the results list to be actual list elements, but in another implementation, we want the results list to be a list of image tags. So this pattern will give us full customizability of every subcomponent, even letting us determine fundamentally what those subcomponents are in different usage scenarios. Now let's go one level deeper. We should provide a minimum query length in order to filter out irrelevant requests. So maybe we can reasonably say that a search with 3 characters just isn't enough characters to really make an informed suggestion about what the user is trying to search for. We can also provide a debounce duration. So if the user is typing into the input field, we don't want to fire off a network request on every single keystroke, especially if they're a very fast typer. So let's debounce the input. That is, we'll actually only send a network request if they haven't made any keystrokes for a certain period of time, maybe like 500 milliseconds of inactivity. This is a pretty common practice for text input fields. We should also provide an API timeout duration. This is useful because in the event that something's gone wrong with the server, we don't want it to just hang forever. It should actually give us some useful error or feedback if it's been idle for a certain period of time. We should also provide some options relating to the caching mechanism, which we'll talk about more at length in just a bit. Very high level, these will include things like initial results. This is where we define what we want the results to show when the user hasn't actually typed anything in yet, but they're still shown a drop-down of options, maybe on like first click into the input component. We also want to pass some kind of configuration for the source of the results lookup. That is whether we want to use caching or not, or maybe like merge the results of hitting the cache and the server. And we also want to pass cache duration. So if we want to explicitly set an expiry for data in the cache. Again, we'll cover each one of these in more depth in just a moment. Now, even though as part of this exercise, we're sort of imagining that we are not the ones working on the server API, as front-end developers, we can still imagine that like we're looking for a server API source that meets certain criteria to power our component. So let's talk about what the server API should provide for us to consider it a worthwhile, usable component in our system. These will be the parameters that it should accept. First and foremost, it will be the actual query, something like this. So here you can see we're hitting an endpoint for /autocomplete and tacking on some query parameters. The query here is our search input. We've searched for Indonesia. And there's also a limit. This is the number of results the end user should see in a single page. And there's a pagination index. This is the page number we want to retrieve. So why is this pagination stuff important? Well, realistically, imagine that like we type in Tom, right? And the server comes up with like 10,000 or 100,000 results that might be tangentially related to the search term Tom. We don't want to just create like a massive list of browser DOM elements for all of these 10,000 elements all at once, right? This will eat up our browser's memory and almost certainly create performance issues. So we need some way of limiting these results. So in the pagination strategy, we basically take these 10,000 results and split them up like pages in a book, and then only retrieve and render the particular page we want to look at any given time. Now, there are alternative strategies for managing long lists of items. One of them is called list virtualization, which we'll come back to later. There's also things like lazy loading. But for now, we'll talk about some network requirements. So every time our input debounce fires, we send a network request. And we don't have any control over how long the server takes to respond. So what happens if we send a network request and the server is slow for whatever reason, and during the time that the server is computing the results, another network request is sent to the server. And so now we have multiple requests in the server going on at the same time, and we can't guarantee the order of the server responses. So we want to make sure that we never display an old response in the UI if there's actually fresh data. So we can do one of two options. We can either attach a timestamp to each request and then only display the result of the latest request, not the latest response. Remember, the important thing here is that the latest outgoing request will have the most relevant, freshest data. Or we can save the results of the request in some sort of map structure with the search query string as the key and only present the results corresponding to that input value. So since we are planning on implementing some kind of a cache, which will remember the responses of each query that we send, option 2 might be more aligned with what we want to go with. And in just a minute, we'll revisit this idea to see exactly what kind of structure might work best for a cache. So what if the server request fails? We can either give the end user some kind of notification saying like, hey, something went wrong, and give them a button to manually retry. Or we can just have the component auto retry in the background. But if the issue persists, we should use some kind of exponential backoff strategy for retries so we don't congest the network and potentially exacerbate the problem. So what if the user's device completely loses network connection? We're fucked. No, just kidding. There's still a few things that we can do to at least make the UX tolerable. We can read purely from the cache. Of course, it's not like super functionally useful to only see the stale results from the cache, but at least in this case, the UI is doing something. We can also prevent the controller from firing any new network requests. That'll save us some CPU cycles. And we can indicate somewhere in the UI that there's no network connection. All right, so let's talk about our cache. How should we design this thing? So we could make a hash map with the search term as the key and the results as the value. So this will give us a pretty cheap and fast O of 1 lookup time. However, this will potentially lead to having many duplicate results. Not great if we're trying to keep memory usage low. Instead, we could create a flat list of all of the results we've seen so far and just filter them on the front end. However, as this list grows, if we have to filter on the front end for every single time we do a debounced keystroke, this could likely affect, front-end performance, lock up the UI, especially when we're talking about slower devices. Also something to think about, results from the server might be returned in a ranked order of importance or relevance to the search term. So if we just stuffed them all on a flat list and filtered that, we might lose this order in the ranking. So how can we kind of get the best of both worlds of these two sort of imperfect solutions? We can create a normalized map of results. So basically we structure the cache like a database. So each result entry is considered like a row and gets identified with a unique ID. And then we can also have a cache lookup. You can kind of think of this as like similar to a legend on a map, which we can use to quickly retrieve what we need from the results. So we get fast lookup and no duplications. So of these solutions, which should we use? Well, if we have a short-lived website, we might actually want to go with option 1. Here, even with duplicate data, the user is unlikely to search so much that the memory usage becomes an issue. And the cache is cleared when the user clicks on a search result anyway. In contrast, if we have a long-lived website, something like where the user will come back time and time again and expect meaningful results based on their previous sessions, Facebook does this, we should probably go with option 3. But we should definitely set some sort of cache expiry limits, as caching results for too long will eventually result in irrelevant responses and can hog memory. So let's say it's the first time the user is visiting our site and using our autocomplete. So on the first hover or click into the component, even before typing anything, we should show them some results. This can be like current events, celebrities, sports, holidays, whatever is popular at the moment. Alternatively, we could also use their own historical searches from past sessions. Facebook, again, does this. If we want to do either of these, we could just create a new entry in the cache where the key is an empty string. So let's talk about caching strategy. We don't want any data to stay in the cache for too long and become stale. This will take up too much memory. So then the question is, when should we clean out or purge the cache? It kind of depends on what our app does. If our results don't change that often, similar to Google, we don't need to worry too much about always making sure our queries return the absolute freshest data. Now, for something like Facebook, where results change slightly more often, we're talking more about like events and status updates, a cache is still useful, but we might want to make sure results get flushed every, 10, 20, 30 minutes. In contrast, if we're talking about some kind of platform where we need like the absolute most fresh results every single time, like a stock ticker or something with like breaking news, we might just not want to use a cache at all. So we can add all of these considerations and preferences as configuration options on the component. The data source will tell us to read either from network only or network and cache or cache only, while the cache duration will determine how long to retain each cache entry for. And basically the way this will work is that each cache entry will get a timestamp. And when the controller component checks an entry in the cache, if the timestamp is past the expiration, then that entry just gets removed and the controller will fetch fresh data from the server and put the fresh data into the cache. Okay, so let's talk a bit about performance. So we need to make sure the loading speed is fast so we can use cached results where applicable. Already covered this, right? We can debounce the text entry or even throttle the network requests in some way if needed. Either of these strategies will limit the overall amount of network requests that we send. We can also manage our memory usage by purging the cache whenever the browser is idle for a certain period of time, or if the total number of entries in the cache exceeds some kind of predetermined threshold. And if we want to try to get super smart about purging like only part of the cache when this threshold is exceeded, we can potentially employ some kind of like a least recently used strategy. I talked about this in my tiny URL shortener video, but my gut instinct here is telling me like this might be overkill for a front-end cache implementation. So I don't know, your mileage may vary. Now here's another cool performance hack you might not have heard of. I mentioned this before. We can use something called a virtualized list to display our search results. This is usually only useful if you have like tens of thousands or hundreds of thousands of results. So what a virtualized list is in this scenario is that if the results contain like a huge amount of items, rendering that many nodes in the UI all at once will be extremely computationally expensive for the browser's memory. So this list virtualization or windowing is when we only render what's immediately visible to the user. So here, what we render at first is a small subset of the total number of elements in the entire list. Then as the user scrolls, the window of visible content moves with the viewport. And the difficulty here lies in this. If we are constantly shifting the visible window, this means we need to delete old nodes as they go off the screen and create new ones for the ones that come on screen, right? Sounds pretty computationally heavy. Well, no, there's actually a better way. We can recycle these nodes instead. So imagine that we're scrolling down on the screen. So the bottommost node is the one going off the screen. But what we're actually going to do is that we're going to take that bottommost node, and instead of deleting it, we're actually just going to move it up to the top of the visible window area's node list. In addition, we can actually give the illusion that the UI contains as many results as the total list by creating fake off-screen elements that add up to the height of the non-visible result elements, while really these fake off-screen elements never actually enter into the visible window area. And here we need to clarify that these are not actually DOM elements. Rather, they're most likely spacers or some sort of like placeholder, like a fragment, which only contribute to the overall height calculation, but don't actually add anything to the DOM. If this sounds complicated, it's okay. Usually with these sort of opinionated patterns, someone has already written a library for it. For example, if you're using React, you can use a library like React Window, and then it's basically just simple plug and play with your own data. So let's go a few steps further and make the user experience even better. There are a few different UI states we should account for. Loading, we're currently waiting for a response from the cache or network, so we can display some kind of a spinner or skeleton loader. These are especially useful on devices with slower network connections. There's also an error state. We briefly touched on this, but if the server responds with an error, we can show an error message with a retry request button. One thing in general we want to be careful with when we're handling errors, this is just a general practice, is that we're not showing the user too much information about exactly what went wrong. For example, maybe we don't want to tell them exactly which of our backend services crapped out, because in certain scenarios, that information could be exploited by malicious actors. Sometimes it's better to just show like a generic, uh-oh, something went wrong. Just food for thought. And if there's no network, we can show an error message specific to that. So what if some of the results coming back from the server are super long? One common practice is to just truncate these responses with an ellipsis if they exceed a certain length. We could also wrap the responses, but imagine that there's like a response that gets wrapped and takes up like 10 lines. That's not super nice. So my preference is to truncate responses, but you can usually leave this decision up to your designer. So how can we make this a bit more mobile friendly? So let's make sure each result item is large enough to be tapped on in a mobile view. We can also potentially show a different number of results depending on whether the user is on mobile or desktop or somewhere in between. However, as a practice, this is usually better left as an option that we give to the user in their preferences. There are also specific helpful attributes we can set specifically for mobile, like auto capitalize, autocomplete, autocorrect, and spell check off. A good way to think about this one is in the case of spell check, if there's a spell check box popping up on top of our results UI box, that could be pretty annoying or make you accidentally click on the wrong thing. Also, spelling mistakes won't matter if we use fuzzy search, right? So what if we have a typo? Fuzzy search is basically a way of searching where the results are inferred based on search terms which are close but not necessarily exact to the term that you're searching. So for example, if you type in Sweden with 2 E's, fuzzy search will also show you results related to Sweden with 1 E. So common misspellings like this are a great reason for implementing fuzzy search. And this is one of those things where, again, you probably don't need to reinvent the wheel by writing your own fuzzy search algorithm. By all means, go ahead if you want to, but chances are someone out there has already built a great library for it. And if you want to know more about how fuzzy search is actually built, I do recommend going and Google searching Levenstein distance. It's pretty interesting stuff. So let's talk about keyboard interaction. Users should be able to focus on and use the autocomplete component using only their keyboard. Some platforms provide a global hotkey shortcut to autofocus. For example, on Google, it's a / key. I don't know if Facebook has one. I couldn't find it. We can click enter to perform a search. Up and down should navigate the results, and escape should dismiss the results. So up until now, we've pretty much run with the assumption that the results will be opened in a box below the search bar. But what if the search bar is currently positioned at the bottom of your browser's viewport? So if we click to open the results, we can do a quick check against the height difference between the bottom of the search bar and the bottom of the page. And if there's not enough space, we can just show the results above the search bar instead. And last, but certainly not least, let's talk about accessibility. As a practice, we should always try our best to make sure that the web is accessible. We want to create a web experience which is functional for all users, right? Including those with disabilities. One of the biggest things that we can try to address here is, for blind users who use keyboard navigation and screen readers, there are certain tooling which turns directives into audio, right? So imagine a blind user is using a screen reader. How do they know that a text input is a text input? Well, we can attach a role of combo box to that input component, and it will literally say to them out loud, like, you are currently in an input component, right? So like semantic HTML and ARIA rules provide this whole extra layer of like rich information so these users can easily navigate our sites. So for lists, we always want to use unordered or ordered lists and list elements. If for some reason that's not possible, or for some reason we specifically need some other type of element for a list item, we can attach a list role to those elements. We should also use an ARIA label for the input because there's no visible label. We can also use ARIA has pop-up to indicate that we can trigger a pop-up element. We can also use ARIA expanded to indicate whether the pop-up is currently expanded, displayed or not. And we can mark the results region with something called ARIA Live. This is a pretty interesting one. Basically, when you mark an element with ARIA Live, you can give it a setting of either off or polite or assertive. And then anytime the content within that element changes, it'll basically like interrupt the process of whatever you're doing to tell you out loud, there's some change happening within this element. And then we can use the ARIA autocomplete model. This will basically tell the user how the autocomplete results will be displayed when on the page, whether inline or as a list or both. So I think that just about does it for this video. I would encourage you to now actually go out and give it a shot at building your own autocomplete component. Have fun. This video borrows super heavily from greatfrontend.com. It is a fantastic resource. This video is not sponsored by them in any way. I just wanted to make sure that this gets boosted because it's helped me quite a lot, and I hope it helps you too. And I will leave a link in the description. So any questions, comments, suggestions, leave me a comment below. And thanks for watching. Have a great day.